Hi everybody, my name is CoBabe Ammann, and I am here to present to you our current state of development for something called the Lunar Science Education Vision. My partner in crime in this is Stephanie Shipp, but in fact it has involved members of the entire Lunar Science EPO community, not just here at NLSI, but beyond. What I'm going to do today is talk briefly about what the vision is and the motivation behind this, and then present to you the recommendations that were agreed on during our plenary sessions over the last couple of days. At the very base, the vision is a set of recommendations based on our understanding of the current state of practice for lunar science education. The idea for this was actually articulated 4 or 5, 6 years ago by the leading lunar science educators, Cass Runyon, Jackie Allen, Marilyn Lindstrom, and others. But it wasn't really until NLSI came along and Doris Dow came along and picked up the ball that we began really working on this in earnest over the last 18 months. What we wanted to do was take a look at where we were with lunar science education. And the reality is that we understood we have a rich portfolio of programs and products for all sorts of audience, but limited coordination of how those products were being used and how they were moving out to audiences, not a very clear set of priorities about what we wanted to do as a community, and not a clear picture of what the gaps and needs were. And so that's part of what this effort has been. The vision sets priorities for the lunar science EPO community, and its audience ultimately will be very broad, policymakers and funders, as well as scientists and EPO practitioners. I do want to emphasize this is not a NASA document per se. Okay, it's completely appropriate that NLSI is leading this effort, but the reach of this document and the development of this document extends well beyond NLSI, well beyond NASA, to the entire lunar science education community. The questions that we started with were pretty straightforward. On a 5-year time horizon, where should lunar science education be, and where should we be as a community? Okay? And so what we did is we began about 18 months ago with a set of brainstorming sessions started here at this meeting, taking a look at issues and audiences and approaches. And over the last year, we developed a summary of all current lunar EPO products and programs for all sources and from all audiences and from all sources. And then we rolled that up and took a look at what we were missing. We did a basic gap analysis. This summer, we took that information and sat down and developed a set of concrete recommendations to be put forward to the broad set of stakeholders in lunar science EPO. I know there's a whole bunch of people in this room that have been involved in this process. If you've been involved in this process, will you quickly stand up? Come on, all of you. I know you're here. There's been about 30 people involved in this in various points over the last 18 months, many of whom are in this room. And so I really want to get across this idea that this is a community effort. We began with an overarching statement, and this will essentially lead the opening of this document, about the need to reignite the public's curiosity about the moon, showing the new and exciting science and its relevance to our daily lives. Why do we start there? Well, you know, research is beginning to make so clear to us that while the moon resonates for those of us that are 40 and over, not saying how much over, but over, and not so much with those of us who are not 40 and over, and yet the moon is our partner, it's our neighbor, it is our stepping stone to the solar system. Conveying the excitement of modern lunar science, the science that you're going to hear in this room all week long, allows the public to understand why the moon still holds a critical place for our present and for our future. And we feel that there is work to be done in terms of bringing the public's curiosity to bear on the work that modern lunar science represents. Now what I'm going to do, because I don't have huge amounts of time, and being, of course, EPO people, we tried to get it down to 3 recommendations, not so much, there are 6. So I'm going to talk to each one of these very briefly. I'm around until the late afternoon. I have no lunch date. So if you want to nail me about any one of these recommendations, I'm happy to talk to you for as long as you like. These recommendations are not in any particular order. I've ordered them only so that they flow for me. We have not decided on any kind of priority at this point. The first recommendation is that we should promote the extensive repertoire of existing lunar content and materials for use with EPO audiences in a coordinated manner. When we did the gap analysis, despite what some of us thought we were going to find, the reality was we have a pretty rich portfolio for all of our audiences, and a lot of that material is really very good. What we don't have is a way to extend that material into new audiences and new situations, and we really feel that as a community, finding ways to do this is critical. So we don't need yet another cratering exercise. I got 20 that work great. Okay? What I do need to do is find ways to bring that really excellent cratering exercise to new audiences. We need to develop an interactive concept map. I'm going to explain what that is, similar to the benchmark 2061 strand maps that allows educators to find standards-based lunar science and engineering education resources easily. If this doesn't sound like anything other than Pig Latin to you, don't worry, okay, but it does say something to educators. It says something very profound. A concept map it demonstrates the relationship between and among scientific topics at age-appropriate levels. It is what teachers use to teach scientific concepts, standards-based concepts, at an age-appropriate level. Here you see just a picture of a piece of the new weather and climate concept map. You can see these are each of these boxes represents a concept for grades 9 through 12. You can see there's some more boxes, and it keeps going below the floor for grades 6 through 8. Each of these boxes represents a concept, and a concept map shows the relationship between all of those different ideas. In an interactive concept map, you would take a look at that concept map on the internet, click on it, and drilling down, you would get all of the resources that met the needs of that particular concept box. It has been done for a wide variety of science disciplines. It has been done for weather and climate. It is currently being done for heliophysics. It needs to be done for lunar science education. Okay. 3, we should engage K-12 and higher education textbook manufacturers to include post-Apollo era lunar science education and exploration strands. I sat down over the last year and I took a look at every single textbook that is publicly available from first grade up through college. With the exception of 2 middle school textbooks where NASA is a partner, none of them had any post-lunar or post-Apollo lunar science education. Oops. We need to do something about that, and it's actually low-hanging fruit. I think this is not going to be that hard to do. Most higher education textbooks, better, but really we can do better than even just the Clementine data. There's enough information coming out of this community that needs to be incorporated in these textbooks. 4, we support the development of higher education materials for use in the classroom as well as for the development of ways for faculty to share their resources. This was the one area in the gap analysis that there was a demonstrated need. There is not a large number of higher education programs and products in our lunar science education portfolio. Now, some of you know me because you've been getting really annoying emails from me asking you to do faculty surveys about the current state of what you need for teaching in the undergraduate classroom. That fed into this recommendation because what the planetary and lunar science community came back with was we need more stuff for our classroom and we want to share the stuff that we have that we think is really good. That's what this recommendation speaks to. We should continue to develop new citizen science programs while at the same time supporting the expansion of existing projects beyond their current borders. Anybody who's been involved in participatory science, citizen science, knows that this is sort of the golden key for engaging audiences of all kinds. You can go this afternoon and listen to Brian Day tell you about some of these programs. We wanted to acknowledge that these programs held a really special place, particularly for the general public, to engage them not just in some specific science, but the process of science. And what we want to make sure is that when we have these opportunities, that we move beyond even the targeted audience and find ways to bring in new and different audiences to them. Lastly, we must meet diverse audiences where they are, supporting new and ongoing leveraged programs that partner with the community and its leaders. This is the only recommendation that does not have the word lunar in it. And it's because it is such a pervasive issue throughout all science education at this point that we felt we needed to leave it as a strong statement just as it is. The reality is that as NASA spends a lot of time and energy talking about diverse communities, we don't do a very good job at it, or at least most of us don't. And some of that stems from the need to go out and reach out to communities where they are geographically, where they are content knowledge-wise, where they are in terms of their cultural connections to the work that we're doing, and finding ways to engage them in long, sustainable, I love that. I'm sorry, it just cracks me. And we think the best way to do that is not just at one-shot deals, but by developing relationships with communities. And I think you can take a look at the work that Daniela Scalise has been doing with the Navajo Nation. She's in her 6th or 8th year of this now. She is finally getting credibility because they know she's not going away, but it takes a lot of effort. It's a lot of work, and yet it's got to be done. How was that for a mouthful? 6 recommendations in 5 minutes. Yes. All right, next steps. We will be writing this fall the draft of the vision for circulation to a bunch of different stakeholders: NASA, non-NASA, scientists, educators, science centers, planetarium, anybody who we think it should see themselves in this document, we're going to try to engage. Some of those will be professional organizations, some of them will be large museums and science, some of them will be small rural communities. Everybody needs to see this in common. Final draft available early in the year for public comment, and we hope to have the vision publicly released at LPSC in March, after which we have some work to do. Building it is one thing. Taking it out and demonstrating to government and organizational leaders why this is important is the next step of this, okay? So anticipate meetings with NSTA and NESTA, AGU, DPS, as well as NSF, NOAA, USGS, and so on. So why am I here? Other than I am learning how to talk really, really fast. This is an invitation for you to participate. And I know you hear this a lot. Come join us. Come have fun. We're doing EPO. Okay, no, this is not going to be fun. I don't want to, it's just like really not. This vision has to have broad support among the lunar science community. The scientific community has to be behind this vision if it's going to get any traction. If you're interested in reading, reviewing, commenting, scolding, arguing, not loudly, blessing, send me an email. Thank you very much.
Pam Clark, Catholic University. Thank you very much for the work you've done so far, and I'm really grateful. Content is extremely important, and it's often lacking, especially recent content in any textbooks. But may I plead for the last two milestones you put up there, 5 and 6 particularly, this is relevant, that we really require, if you want to really truly reach people and excite the next generation about science, you have to do STEM. You have to use a slightly new paradigm, and believe me, the exploration, the moon is a great target to look at the combined efforts of science, math, engineering, and technology development. It's absolutely perfect, but you have to shift the paradigm a little bit, and NASA does very well looking at content focused on particular targets, but you have to look at stories. You have to look at the whole context. You have to look at exploration, and it's a perfect opportunity for people that have been underrepresented to actually participate in looking at the stories that they engage in and talking about their own explorations that are part of a cultural context. I'd love to talk to you offline about this, but I really believe it's absolutely critical, because I think that the filling up the cup with data on particular targets model, days are numbered now. It's not going to continue to hold people's excitement.
Okay, thank you. Mm-hmm. Yes.
In New Mexico, and I suspect nationwide, in higher education is distance learning and online education. And so I wondered whether you've sort of tried to fold that in looking at the needs and gaps in terms of the materials that are available.
Let me tell you where it is showing up, and it shows up in the recommendation that talks about higher education development of materials. It's become, most of what I do is in the area of higher education, and so it's become clear that a lot of our materials, while well suited for being in the classroom or in the lab, not so good in the area of online education. What I have been trying to do is convince some of our higher profile higher education faculty members to come together and put together in an e-pose that translates their material into situations that can be used for online learning. My job is not to actually write the proposal and do the work, it's to get them to do it. But I can be pretty persuasive, and I'm suspecting that we're going to start seeing some of those proposals.
Brian, one of the audiences you haven't mentioned always fascinates me. At the time of the Apollo, the Gallup poll said that 7% of Americans thought the Apollo was a fake. I've seen some European samples with younger generations where it's up to 25%. Now, are you going to address that, or do you don't want to give them any oxygen?
No, I think you have to. Where it comes. So we have science and we have engineering, and then we have misconceptions. It's in our. We've built it so completely into our content that rather than give you that whole list, which includes misconceptions, we talk about audiences. But we see it at every single level. We see that misconceptions, and it's not just did we go to the moon or not. There's so much. Honestly, if I asked middle schoolers if the Earth was flat, half of them would say yes. And that's where we are. It is about good STEM education, but it is also this notion that, you know, it's one thing if students are honestly uninformed, but when you have vectors in your community that are intent on propagating that misinformation, that becomes even more challenging. I would say that everybody in the EPO community understands those misconceptions well. People like Doug Dunk and Tim Slater have done a lot of research on what that means and what it looks like in their classroom. It is definitely on our radar. Thanks.